Hey guys, this is Mr. Beckstrom, and today I want to take a look at a couple of examples from section 1.6. This is kind of like miscellaneous equations. You're going to see a variety of different equations, including absolute values, some things with square roots, just some different kinds of things that we need to have a couple of extra tools in our toolbox to kind of solve these. This is a really good section here to kind of go through the examples in the actual book, try them out, and then see kind of what they did to solve these. For the first one, we're actually going to use some of the tools that we're going to learn in 3.1, 3.2, and 3.3 to solve this one. So here it says find all the real and imaginary solutions to the equation, and we're just given a third degree polynomial. Now remember, if we're just given a second degree polynomial, we have a lot of tools to solve those. We have the quadratic formula, we can try factoring, we can complete the square. There's a lot of things that we can do. But with the third degree, we really need to find a root somehow before we can kind of simplify that down to a second degree polynomial. So the rational root theorem is a pretty good way to start that, and that's the P over Q. So we look at where the last value here, the number, the scalar, what am I thinking of? Sorry, the constant, that's all the factors of the constant is our P, and all the factors of the coefficient of our highest exponent term, so that would be 1 here because that's the constant in front of the n, would be our Q. So here we're looking at all the factors of 7, which is just plus or minus 1, and plus or minus 7. These are all the numbers that go into 7, all over all the factors of 1. So that's just going to be plus or minus 1. So you look at all the numbers of these divided by all the numbers of those. So that's just going to be plus and plus or minus 7. So that's 4 total value. So if there is a real rational root in here, it's got to be one of these 4 numbers. It has to be a factor of this number divided by a factor of this number. So I'm going to use my calculator to check these. So what I'm going to do here is second quotes. It's not. All right, quit. All right, so clear this out. So what I am going to do is go ahead and go to my y equals, and let's clear all this out. I was using that for another class, so we're going to put this equation in here. I'm just going to use x, it doesn't matter which variable you use, so x cubed minus 7x squared minus x plus 7. So remember, if we put a value in here, if we evaluate this function at one of these values and we get a 0, that means that that value is a root of our function. And I'm going to try those 4 values here. So 1, -1, 7, and -7. And I'm going to do that kind of simply with the table. So make sure I go to second window, that's my table set. Make sure my independent, that's my x variable, says ask, and my y variable, my dependent, says auto. So that looks good. So I'm going to go to second graph, which is my table. Let's delete all those. Looks like I already going to have a couple of those, so that's nice. But I'm going to try 1. So since I got a 0 there, that means 1 is a root. -1, which I think that's also a root. Let's go ahead and try the 7. Hey, look at that, and -7. So it looks like all 3 of those, 1, -1, and 7 are all the roots. And remember, since it's a third degree polynomial, that means I have exactly 3 total roots. So since I found them all, I'm done. So it says find all the real and imaginary solutions. So they are 1, -1, and 7. That will satisfy this solution. And if you were to try them and put them in here, sure enough, they would all equal 0. So, well, this is an n, so we can say n is equal to 1, -1, and 7. So that rational root theorem did us good here, because 1 cubed minus 7 is -6, minus 1 is -7, plus 7 is in fact 0, and that was with the 1. You can check with the other two as well. All right, so that one didn't turn out so bad. If we had just found one of them, then we could have used synthetic division. Let's do that. Let's just say, so let's just say that we had only found the 1. Let's just say we had only found the 1. And I wanted to use synthetic division to turn this into a second degree polynomial. I could have taken that 1, pulled it out here, and used synthetic division on the other. So the coefficients are 1, -7, -1, and 7. So 1, -7, -1, and 7. So I bring the 1 down. 1 times 1 is 1. -7 plus 1 is -6. 1 times -6 is -6. -1 plus -6 is -7. 1 times -7 is -7. And of course, the last thing should add up to 0. That means when we take out the factor n minus 1, which is the root 1 here, because that's the factor that's associated with it, then we are left with this second degree polynomial. So that would be n squared minus 6n minus 7. Just using these remaining coefficients. And then if we wanted to find the remaining roots, remember this is all equal to 0. I could have factored this right here, setting that equal to 0, and I could have found them that way. So that would have been setting up my n's. Hopefully we've done some factoring before and we feel a little bit comfortable with it. So I need to find two values that when multiplied together give me a -7, and when added together give me a -6. And that would have been -7 and +1, because 1 times -7 is -7, and -7 plus 1 is -6. So these would FOIL into this. And then if you set each one of these equal to 0, you would have gotten the other two roots as well. So you could have done it that way if you just found this one. But luckily, that rational root theorem was nice enough to give us our other two roots in the process. So, yay! All right, so there's also another one I wanted to take a look at. I don't want to keep this video too long, but I want to give you some nice things to work on. So here we say solve the equation and check your answer. Now there's a good reason that it says check your answer, and that's because when we're dealing with square roots like that, we often have to square both sides. And whenever you square both sides of an equation like this where we have variables in there, we're often going to get what's called extraneous solutions. And extraneous solutions is a big word for extra solutions. That means solutions that do not work in the original equation. So that's why we have to check that. So if you basically square both sides or you multiply both sides by extra variables, you're often going to get those extraneous solutions. You've got to watch out for that. If you've ever seen those Facebook tricks where you start off with a number and then you do a bunch of multiplying both sides by like x's and stuff, and then you end up getting a number is not equal to a number, a lot of times that's due to the extraneous solutions. All right, so here we have this. What I'm going to do is I'm going to go ahead and square both sides to get rid of the radical. And when I do that, I got to look out for extraneous solutions once again. But that'll get rid of the square root over there. So I'm going to get an x squared plus 13x minus 14 is equal to 4 squared, which is 16. And then this is something that I can go ahead and solve. So I'm going to subtract 16 from both sides. So x squared plus 13x minus 14 minus 16 is minus 30 is equal to 0. So that's something that we can go ahead and try to factor here. So I have an x and an x. So kind of like the other problem, I need to find two values that when multiplied together give me a negative 30, but when added together give me a positive 13. It's not too hard to find, so that's going to be a positive 15 and a negative 2. Negative 2. And notice that negative 2 times 15 is negative 30, and negative 2 plus 15 is positive 13. So I can set each one of these equal to 0. Therefore, I get x is equal to 2 and negative 15. But now I need to go ahead and check both of these. So if I put the 2 in here, I'm going to go ahead and get 2 squared, which is 4. 4 plus 13 times 2 is 26. So 4 plus 26 is 30. 30 minus 14 is 16, and the square root of 16 is 4. So that looks good. Now this is a keeper, so a little box around that. Now let's check this negative 15. So negative, let's go over here. So we have a negative 15 squared, which is 225, plus 13 times negative 15. So let's pull out the calculator. So 13 times negative 15, negative 195. So plus negative 195 minus 14. All right, so this is going to be, let's go ahead and bring that down. So this is going to be 225 minus 195 minus 14. And sure enough, we get 16. So we're going to get the square root of 16, which also happens to be 4. So in this case, we do not get any extraneous answers. So both of these happen to work as well. So we have 2 verifiable good answers. All right, that's all I have for you today. Try to keep these videos under 15 minutes. If you have any questions, let me know, and have a great weekend. Thanks.